Hey everybody, this is Mr. Munson, and we are in Chapter 5, Triangle Relationships. So we're looking at triangles and the relationships that different things that are associated with triangles have with each other, like segments and angles and things like that. So this is concept number 2, hence the name 5.2, Special Triangle Segments. Let's get started. Now before we get too far into this, I want to make sure that you and I are on the same page when we're talking vocabulary, solving equations, and things like that. So let's take a real quick refresher. Suppose I was given this problem. Find AB is given. Find AB given B is the midpoint. That's a code for what to do with this problem. Okay. So the fact that B is a midpoint tells me that I should come in here and mark these two pieces congruent. That's what midpoint means. It means it takes a segment and cuts it into two equal parts. Now the drawing doesn't look that, and I could care less. The fact is B is a midpoint. That's a clue to what to write as an equation to solve for that x. Now, of course, the reason I want to find x is I'm going to plug it back in to the expression for the segment AB, and that'll give me the answer that I'm looking for. So I go ahead and write the equation 3x plus 2 equals 4x minus 1, which is a clear indication that I understand that when two segments are congruent, they are equal. I go ahead and subtract 3x from both sides, and I get that. So I add 1 to both sides, and I get x equals 3. Now it's just a matter of plugging it back in for AB and getting the calculation for that. So let's plug 3 back in, and I get 9 plus 2 is 11. So that, my friend, is what AB is equal to. Now for me personally, I'm going to plug the 3 in. I don't need to for BD. I'm just going to confirm that both sides are equal to each other. If for some reason it didn't, that would tell me I've done some calculation errors. So I plug 3 in. I get 4 times 3 is 12. 12 minus 1 is 11. So I'm walking away from this problem pretty confident I did it right. How about this problem? Find x given AC is an angle bisector and angle BAC is equal to 3x plus 2 and CAD is 4x minus 1. Let's mark it up. That's the indicators that AC is an angle bisector. It cuts it into two congruent angles. So since those are angles, I'm going to put those measurements inside the angles. Since they're congruent, I can write the equation that those two things are equal to each other. And once again, x is equal to 3. Now that's an angle measurement that I'm working with. So to find out, if it was asking me to find an angle, I'd plug it back in. In this case, it's just asking me to find x. So there's my answer. All right, let's take a look at this one. It says find x given AD is perpendicular to CB. I'm going to pause right there and recognize that before I go any further. And I suggest whenever you're reading these things, you do the same. So it says it's a perpendicular. So that's code for that these are right angles. Okay, so we'll go ahead and mark those as being perpendicular. Of course, perpendicular means that these are 90-degree angles, isn't it? So I don't need to write the 90 myself. I know that it's the little box symbol represents 90 degrees, but you might need to. Okay, so then let's mark it up with the rest of the information about CD and the angle ADB. Put me on pause and see if you can get that right, putting it in the right place. Okay, so hopefully you put those in the right place. Now it's asking me to find x, so I have to write a relationship between some things to find out what x is. Now a lot of times students will take that 3x plus 3 and the 4x minus 1 and relate them, and they can't because the 4x minus 1 is actually side length information and the 3x plus 3 is an angle information. So we don't want to set those equal to each other or pretend that I can add 4x minus 1 to 3x plus 3 and get 90 or 100. Those things are two different kinds of things. One's a side, one's an angle, so certainly they don't add together to give me 90 degrees. It's completely different. So I have to look at and analyze and decide what it is I can do. Well, this is the deal. I know that that angle right there is 90 degrees. It's also 3x plus 3. So I get to write the equation 3x plus 3 equals 90 degrees. We did that at the very beginning of the year. If you don't remember it, that's why we're doing the refresher. I'm going to assume that you can solve an equation like that. Let's move on. Okay, starting with our very first special segment. It can be array, a segment, a line, but I'm just going to refer to them as array, a segment. It doesn't matter. We're all talking the same thing here, basically. So an angle bisector is an array or a segment or a line, it doesn't matter, that divides an angle into two congruent angles. In a triangle, that's exactly what it would look like there. Okay, so what we do is we'd want to come in and mark those angles as being congruent. There's different ways that we mark congruent angles, but that's just one of them. Here's some characteristics that you would want to write down and memorize that go along with an angle bisector. Creates two congruent angles. Each triangle, each angle has its own angle bisector. In other words, in a triangle, there's three angle bisectors. Hey, all these angle bisectors, they meet at one point, and finally, it creates some special proportions. So let's talk about that first before we go too much further. So take a look back at the drawing to the left, and you'll see I've entered in a lowercase a, b, c, and d. And in no particular order here of letters. Matter of fact, I think I'm going to go ahead and move these into place like this. Okay? So what ends up happening when I say it creates some proportions, proportions are four things being related. Four things being related. And as you can see here, we have the original side over here, another original side, and then down here, a side that's been busted up into two pieces. Okay? Now, D in this case does not have to be a midpoint, okay, so don't make that assumption. An angle bisector just simply bisects an angle. But what it does do is it does divide it up into two pieces, a D and a C in this case. Now, what's really cool is that those pieces, four of them, can be written as a proportion. And in this case, it's going to be A is to D as B is to C, which is fabulous because that's what it looks like. It looks like A is over D and B is over C. Now, it gets a little bit complicated, more complicated if the drawing kind of gets rotated or whatever, but that's part of problem solving, trying to figure out where the pieces are once it rotates or it gets a little bit more complicated. Okay? For now, remember, it creates a proportion. Proportions are made up of four things that are all related. And when I talk about a relationship, it's typically either an equal sign kind of problem or a inequality that's with less than or greater than. Go ahead and draw a triangle that's similar to this. And what I want you to do is put me on pause and then do your very best to angle bisect, okay? I'm going to readjust my red line there to be more like something that looks like an angle bisector. So I've just adjusted that one to make it look more like an angle bisector. That looks like two angles that are a little closer in, you know, that look a little bit more congruent. That's maybe even better. Now what I want you to do with C and A is I want you to just draw your very best angle bisectors. Just put me on pause and make a freehand drawing of that. If you didn't do it, you're probably worried that it might not look right. And as you can see, mine's kind of, screwy. But it's not too bad. But what I wanted to point out is that all these angle bisectors meet at one place. Okay, so if you've done your angle bisectors correctly, they'll all meet at the same place, or very close to it. Since we're free-handed, there'll be some error there. Let's move on. Next up, a median. So a median is a segment that connects a vertex to a midpoint. So D in this case, a midpoint. And you can tell that by these marks here that show that they're congruent. Okay, so there we go. So here's some characteristics of a median. It bisects a side, certainly. Each angle has its own median. That means there's three medians in a triangle, and all three medians meet at one place. Okay? So just draw yourself a triangle real quick, and it can look like mine, and then start drawing its medians. Just put find the midpoints of each side, right? Just grab and estimate it. It's about here, about there, whatever. And then grab a vertex with your pencil and draw straight to the midpoint across from it. Do that 3 times, okay? And come back and just see if you've done it correctly with me. Cool. Now there's one of my angle or medians. I just simply found the midpoint. And I just estimated it and then drew a vertex, and there's the other one. And as you can see, they all three meet in this case at a point there. All right, let's move on. All right, an altitude. An altitude is a perpendicular segment. Remember, perpendicular means it forms a right angle. Okay, a perpendicular runs from a vertex to an opposite side. That's perpendicular. Okay, so here's one. Kind of make sure this extends up here. All right, there we go. Now, it doesn't necessarily divide anything. It's just simply going from one vertex to the opposite side in such a way it's perpendicular to it. Okay, and we should be able to eyeball that at this point of the game and understand what perpendicular means. Here's some characteristics of a perpendicular or an altitude perpendicular to a side. Each angle, B, A, and C, and all that stuff, have their own altitude. This is basically the height of the triangle from a different altitude, from a different vertex, okay? So height of a triangle is usually referred to when we're talking about altitude, and it's the distance from a vertex to an opposite side. So what I want you to do is I want you to go ahead and draw a triangle that's similar to mine, okay? It's obviously an obtuse one, and we're going to look at doing the altitudes to this together. The reason is because when it's an obtuse triangle, altitudes actually sometimes appear outside the triangle. Okay, so we're just going to take it one step at a time, making sure we're looking at it. I like to rotate my triangle, so you might rotate your paper to kind of get a perspective of where the altitude's at. So there's a first altitude, and again, I'm rotating it to show you kind of how you might, a tool you might use in order to do it on your paper, okay? So now I've just moved that A to the top. That's kind of like, so it's up the top, but I made it so that this side right here, this bottom side, was kind of parallel to the bottom, so I could kind of visually see it. Now, if I try to draw the altitude such that it's like this, you can see that line's nowhere near perpendicular to that side. So this is the kind of special case. What we're going to do is we're going to extend a side. So we're just going to bring it out like this. If you look at it in the sense of perpendicular now, perpendicular to the altitude is actually outside the triangle. It's very unusual, but that's where the altitude is. So draw that in, put me on pause, whatever you need to do, rotate your paper so you have it. Now what we're going to do is we're going to rotate it so that this side right here is horizontal, so I can kind of eyeball it as well. Okay, stay with me. All right, here we go. So we're just rotating it so that that one side that still doesn't have an altitude is nice and horizontal. Now again, this might represent you rotating your paper. So I'm just going to take this remaining side and I'm just going to extend it horizontally, because this point up here comes down right here, and that's perpendicular to that. So sometimes we have to draw them on the outside. Okay, so as you can see, the altitude can become a little bit complicated just because we're talking about extending sides. So just to make it easier on my next step, I'm just going to turn it this way. And what I'm going to do now is kind of think through what each of my altitudes look like. And I'm just going to extend them. So I'm taking the blue one. I'm just going to keep it going. Okay. Now I'm going to get the green one and extend it in this direction. See, what I'm trying to do is find a place where they all go out and meet. So let's extend the red one, and they all meet right about there. Okay? So what's kind of cool is that they all meet at one point. In this case, they meet outside the triangle. Now, if you're like me, that looks really complicated. So it's not that I stay away from it. It's just that I have to do it piece by piece to think it through. Perpendicular bisector is basically a segment that comes down, and you find this midpoint, and so it's a special line that comes down. Not only it hits at the midpoint, but it's perpendicular. Okay. Now over here we have some of the characteristics of a perpendicular bisector. Now these are the only ones that do not connect right now. The only one that does not connect to a vertex. Okay. So in this case, it's bisects a side. It's perpendicular side. Each side has its own. In other words, just three of them, and they all meet at one point. So see if you can take and draw a drawing like this, and see if you can write the perpendicular, draw in the perpendicular bisectors. Just find your midpoints and then do your best to eyeball those perpendiculars. Put me on pause and come back and check. Okay, so I always like to draw the midpoints in first, and I just start drawing my perpendiculars. The more you do this, the better you are at eyeballing what the perpendicular is, and you don't get messed up by the other sides. Now again, these all meet, and so let's just extend them. I can kind of see where they're going to come down and meet. Well, I've made some kind of mistake, so let me just pause for a second and see. And it was just that blue one was a little bit awkward, and right now we're just freehanded, so if they didn't exactly meet, that's no worries, but it gives you an idea if you're doing it right. All right, so mid-segment, this is our last one. Mid-segment is basically a segment with two midpoints as its endpoints, right? So as soon as we start talking about midpoints, then we know we have pieces that are congruent to each other, okay? So sometimes it's just eyeballing them. All right, so some characteristics, bisects a side. Each So each two sides have their own. In other words, it takes two sides to make one of these segments, right? And there's three total. The segments are parallel to the third side. So as you can see with my blue arrows there, I'm connecting the left and the right side here to make the mid segment. The side that's not being used, the bottom one, that one is automatically parallel to that mid segment. Go ahead and put me on pause and see if you can draw in the other segments. So after eyeballing where the midpoint was on that bottom one, it's just there's a connection. I'll connect the other one here. All right, there you go. And those are the three mid segments. Okay, let's go ahead and draw a line and do a real quick summary. Maybe state what the name of the special segments are, maybe a quick analysis of what they are, or maybe just 5 pictures, whatever it is. But do a summary to help solidify the ideas. And that means we're done. So here's your do it problems. I'll zoom in so you can see them a little bit better. And then we're out of here. Okay, let me scroll through them so you get them. And there you have it. Thanks for watching. I hope that clarifies some things that when you come to class next time, we're working through it and just practicing these properties. Take care.